Let us study convection of heat. We are going to just take up an overview of convection of heat. Detailed analysis of convection is beyond the scope of these lectures. So right now we are not getting into the mathematical analysis of heat convection. And as just convection is concerned, we can simply state this is transfer of heat by actual motion of material, or more precisely material particle or particles of medium. Mainly we can say there are two types of convections. Very first is natural convection, which is basically due to variation in density. And the second one is forced convection, which is basically accomplished by using a pump or a blower. When we just talk about natural convection, it is a simple phenomena under which we can state when a fluid is heated in a zone, its density decreases, and the high temperature substance, which is lower in density, will be raised up against gravity. Like you can say, we are having a container in which say water is filled, and say by using a burner we heat the water. We know well that by conduction through burner heat is supplied, and in the zone which is at the bottom of this water, temperature increases, and due to increase in temperature its density decreases because of thermal expansion. And as density decreases, these water particles will start raising up. Now other water particles which are cold and having high density, they'll come down and will occupy the lower zone. So we can say gradually as heat is continuously being supplied, continuously the density of lower zone will be decreasing, these water particles will be going up, and the surrounding water particles which are at low temperature having high density will come down. So due to these continuously, you can say these hot particles will be going up, carrying the heat from bottom zone to the top zone, and other particles which are cold will occupy the spaces in the lower zone, gets heat up, then raised up. We can state continuous flow of these particles will start due to variation in temperature or variation in density. This continuous flow we call convection currents. And by these convection currents we can say the water at the top will also get heated, because actually water particles are carrying heat from bottom zone to the top zone. So this transfer of heat from bottom zone to the top zone is called heat convection, and such continuous flow of physical particles we call convection current. This is a natural convection. Let's discuss a very good illustration for understanding natural convection. Say we are given with a U-shaped tube in which water is filled up to, you can simply say, a given level, and in the right arm of U-tube a tap is connected, but water is not filled up to the level of tap, and on the other side the tube end is open, which is below the level of tap. Now in this situation, say if we put a burner and we supply heat just by lighting on the burner, we can simply state the water which is there in the right arm, its temperature will increase. Obviously if its temperature will increase, its density will decrease. So we can state if the density will decrease, the water level in this right arm will start raising up. As soon as it will reach the level of tap, it will start flowing through the tap as the tap is open. As soon as it will start flowing through the tap, the water level in the left arm will start increasing, and due to increase in pressure, this will push water to flow from left side to the right side, which again gets heated up, moves up, and continuous flow will be established here. And we can simply state, as the water is heated in this zone, physically these heated particles are flowing, moving, coming through the tap, and throughout the region of this tube we can say water will be heated because the water particles are taking heat from burner and continuous flow is taking place. So this continuous flow of water particles we can simply state as thermal convection. So we can always state natural convection is basically due to variation in density, which we already studied. So I think you can keep in mind that there are lot many examples which will explain the phenomena of natural convection. So just keep the concept in mind. This is a very good example to understand natural convection. Let's discuss the analysis of heat current due to convection. To understand this, say we consider a hot surface which is at temperature T1, and say its top layer surface area is A, and say just in front of it we put a blower and we switch it on. Then due to this blower the air will be continuously blown over the hot surface. When the air blows over the hot surface, the air particle which comes in contact with the surface will certainly extract heat from the surface and the air gets heated up. See, the main body of this fluid which is flowing over the hot surface is at temperature T2. This temperature will be raised because of extraction of heat from the hot surface by convection. So we can state in this situation the rate of removal of heat from this hot surface due to convection is called convection current. And in this situation, the first point we can write about it is, say it is dq by dt, the rate of flow of heat. It will be directly proportional to the surface area in contact. We can write in case of heat convection, this rate of heat extraction from the surface will be directly proportional to A, which is the area of surface in contact with the fluid, which is the mean substance for convection. And another thing we can write here is dq by dt is directly proportional to difference in temperature. Here delta T can be written as T1 minus T2, where T1 is the temperature of the hot surface from which heat is extracted, and T2 is the average temperature of the mean body of fluid to which the heat is taken. So we can write from these two relations here dq by dt can be written as directly proportional to A delta T, or this gives us dq by dt is equals to H A delta T, where H is the constant of proportionality. In this situation we call this H as convection coefficient. So here we can state the rate at which heat is extracted from the surface in case of moving fluid in its contact is given as HA delta T, which is directly proportional to area of surface in contact and the difference in temperature of surface and the fluid body. And H is a convection coefficient which depends on many factors like the nature of surface, the characteristics of the fluid medium which is used for convection, and this relation is a simple analysis for convection heat current, and there are many applications based on this relation which you will see soon.